Hello. Today we're going to have a review of statistical data that covers mean, median, mode, our central tendencies. It covers our measures of variance, which is range, MAD, variance, and standard deviation. It covers z-scores, and it also covers my box and whisker plot and my stem and leaf plot. So first, number one. Number one tells us, when would the median be a better representation of the balance point of a set of data instead of the mean? First of all a balance point is the middle of my data. That's all a balance point is. So it's basically just saying the balance point is the middle of the data. So when would the median be a better representation of the middle of my data than opposed to my mean? Because as you know, the mean and the median should be around the same number. If I take an average of all my numbers, they should be around where my middle number is. That's why it's called a balance point. So when would the median be better than taking that mean? Excellent. We talked about this in class. It's when you have an outlier to skew the data. If I have an outlier, then we know that I have a data point that's either pulling down or pulling up my average for my class. You kind of see it when you have a 100, and a 0. You don't have a 100 average, you got like a 66 average because it pulls down that mean. But if I was to take the median of those three numbers, I'd still be around 100, which is more representative of my grade. So an outlier skews the data, so a median is a better representation. Okay, second of all, outlier, just because I'm thinking about it. To find the outlier, remember, if there's an outlier, it is your interquartile range, which is the range of the box, times 1.5. So I get that number. With that number, I then take quarter 1 and subtract it. I take quarter 3 and I add it. Anything beyond those is an outlier. Anything that sits past those is an outlier. Just as a review, it was on the box and whisker notes. The next one is it's a vocabulary question. There's a lot of vocabulary on your test. And this next one is a vocabulary question. It says, what is qualitative data? And then which measure of central tendency can be used finding qualitative data? So there's two types of data. We didn't really talk about this too much. There's qualitative and there's quantitative. With qualitative data is data that isn't numbers. So what data is not numbers? I could ask for favorite food. Then it would be M&Ms, pizza, hamburgers. I could ask for music, classic rock, country, that kind of stuff. That, when you're getting an answer, that is not a number. Because quantitative, quantity means numbers. So it's data that is numbers. This is not numbers. So all of our data we have dealt with so far is qualitative. We have not asked you your favorite music. We have not asked you your favorite food. So all the data we have done is quantitative. It's all quantities. It's all numbers. So it says here, What measure of central tendency would I do with qualitative data? Well, the only thing I could do with it is what? Exactly, mode. Mode is the only thing I can do with central tendency that is done with qualitative data. Because qualitative data is data that is not numbers. So the only thing I can say is who likes hamburgers the most? Who likes, what do you all like better, rap, country, or R&B? That is qualitative data, and I can only find a mode with it. Okay, number 3. How do I find the range? The range of my data is the range of my largest number subtracting my smallest number in the data set. Some of you confuse that with interquartile range on your take-home quiz. An interquartile range is the range of the box in a box and whisker. And some of you confused the two on your take-home quiz. You found the range of the data instead of the interquartile range, or vice versa. So be careful. Range is the whole data set. Interquartile range is just my box. All right, number 4. Get your calculators out, get ready. It says on number 4, it says, find the mean, median, mode of the frequency distribution below. Go to the nearest tenth if needed. First of all, before we get started, we got to talk about this data. You will have a frequency table on your test. It's important that you understand frequency means the number of times it occurs. So therefore, this number 5 has a frequency of 5. It means 1, 2, 3, 4. There are 5 of them. The number 11 has a frequency of 2. That means I have 2 11s. The number 3 has a frequency of 6. The number 3. Sorry about that. Wrote the 6 instead of the 3. Let's take a quick white out. There we go. So it's 3, 3, 3. The number 3 is repeated 6 times. Sorry about that. The number 9 is repeated 10 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm a classic example of what I just did to what you do that's incorrect. Be very careful and write it out. It takes 2 seconds to write it out. When you're given a frequency table, write it out. Because now, when I go find the mean, the median, and the mode, then I'm looking at my data. I'm not just looking at my data crunched up. And some of you look at the data crunched up, and then you try to find things of just these numbers instead of this is the big data. This is my data set right here. That's what I'm using to find the mean, median, and mode. So, first of all, easiest one on there is mode. Why? Because we know that right here it says the 9 occurred 10 times. It occurred 10 times. So who is my mode? Exactly, 9. The median, we're going to have to list all these numbers in order from least to greatest and count to the middle, or we can be super savvy and put them all on my calculator. Either way works. You need to be careful if you're counting to the middle number. That one, they're in order from least to greatest. Doesn't matter if you're doing it on the calculator will order it for you. So if you're super savvy, remember that one VARS stat button, when you scroll down, has that information for the median. And it also has the mean, so you don't have to use that extra stuff we talked about later. So, let's find our median. We're going to put them in order from least to greatest. Then we're going to count to the middle. All right, so now, if I want to find it the old-fashioned way, I just start counting to the middle number. That's what the median is when they are in order. So my median is 9. My mean adds up all these numbers and divides by the total in the list. The mean is my average. So now, to find my average, I'm just going to have to take my calculator and add all these up. There's nothing else I can do. Okay, so you added up all your numbers. When I added them all up, I got 155. I'm going to divide by the total in my list. Not my total in my list, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to 23. And my average ends up being 6.739, which is about, does it say to round to the nearest tenth? So I don't even have to go that far, 6.7. So, to recap, my mean, 6.7. My median is 9. And my mode is 9. Alrighty, number 5. Moving right along. Number 5 says to find the deviation from the mean for each of the following elements. Then find the sum of their differences. Okay, so first, the deviation. Deviation means the difference between the data point minus my mean. That is a deviation. You need to know that. That's that piece of the formula that keeps getting used. What I'm going to find first is, because it's from the mean, the first thing I'm going to have to do is find the mean. Then I'm going to have to find the deviation. Because everything we've done has set up a chart, I'm going to make a quick chart. That's the part of the chart we're talking about. That's the deviation. So the first thing I'm going to have to do is find the mean. So what's the mean of my set of numbers? Correct. It is 70.16, but I'm going to go ahead and round it to 70.2. It's 1/6 repeating, I believe. 70.2 because we're doing a lot of subtractions. So my deviation is just 72 minus my mean. 66 minus my mean. 67 minus my mean. 69 minus my mean. 73 minus my mean. 74 minus the mean. Now it says to find the sum of the differences. So it's just asking you to sum that guy up. So all I'm going to do is take them and add them all together. So 1.8 plus negative 4.2 minus 3.2 minus 1.2 plus 2.8 plus 3.8. The sum should be negative 0.2. And the purpose of this is that if I take the sum of the absolute values, and the sum should technically, if you remember we did this, the sum should technically be 0 or very close to 0. Because I rounded it, that's how come it's not 0. But technically, if I subtracted all of these and added all of these, because remember we had that number line, and we had our average here, and then we talked about how far they deviated off the average. So I had 1.8, I had negative 4.2 way over here, I had negative 3.2, negative 1.2, I'm just making up places here, 2.8. The thing is these differences from the average should all average out to end up being at, oops, where did I put 0? At, sorry, I didn't put the thing in the right place. Should average out to being right here at 0. Their distance should be 0 by the time they average out on both sides. They should be. So it's very close because it means I rounded. No big deal. So that's how you can check if you found the deviation correctly. It should be right around 0. All right, you have a question like this on your test. It's going to say, for the following data, find the mean absolute deviation. Again, mean absolute deviation is my MAD. Find my variance, find my standard deviation, and round to the nearest hundredth. All right, so I'm going to make a chart because that's the only way to find MAD. So all right, the first thing I'm going to have to find is the mean of my data, because no matter what I do, my first column of my chart to find my MAD is going to be my deviation. My deviation is my data point minus my mean. So I'm going to take my mean, so I have 72 plus 66 plus 67 plus 69 plus 73 plus 74 divided by 6. I'm going to round that to tenths. Why? Because it's a lot of subtraction we're going to be doing in this chart. So it says to round my answer to the nearest hundredth. We're talking the final answer. It's okay if you take the mean at this point and make it 70.2. And actually, this is the same data from the other page, so I shouldn't have had to find the mean again. All right, we already found the deviation on the other page as well, because I believe this is the same data set that we just did. 72, 66, 60, exactly the same data set. So I already know my deviations. I did them on the other page. But again, it's 72 minus the mean, it's 66 minus the mean, 67 minus the mean, 69 minus the mean, 73 minus the mean, and 74 minus the mean. And you will have one that has all of these together because we don't want you to have to find the same rote mathematics 4 or 5 times. All right, so for MAD, this is my MAD column. My MAD column. So under my MAD column, I have to find the absolute value of this, then add them all up and divide by 6. That's what I got to do. Okay? So, absolute value, distance from 0. Makes them all positive. So now when I add them all up, I get 700. Oops, I add them. And I get 737. When I divide that by 6, I didn't get 737. I lost a decimal point. Sorry about that. I put in a wrong number. Let's try that again. Sorry, Miss Singletary. That was bad. 1.8. But I knew right away my number was way too large. How about 17? That's a much nicer number. 17. 17 divided by 6 makes my MAD 2.83. Because it says round to the nearest hundredth, and the 3 repeats. So that's my MAD. That's my MAD. Now, with that, we could put it on our calculator. So I'm going to show you how we can do variance and standard deviation quickly on the calculator. MAD you cannot. I will also do it longhand to verify our answer. So the first thing I'm going to do is get my calculator. Sorry, let me clear all that stuff I've done. I'm going to go ahead and I'm going to go into Stat Edit. I'm going to clear my list because obviously I didn't do that before we started. I'm going to put these numbers in because that's the first thing that has to be in my calculator. So 72. Oops, why am I plussing it? That was bad. Let's try again. 72, enter. So I have my 6 numbers in my L1 by Stat Edit. So now, if I want to find variance and standard deviation quickly, it's that 1-bar Stat button has everything I need to know. So I can come here under Stat, Calc, 1-bar Stat, enter twice. It tells me right there that my average, which is my mean, is right here, 70.2. That's what I got. It tells me right here that OX is 3.02. OX is standard deviation. Variance is O squared. Standard deviation is just the plain O. And on the calculator, it's OX on the calculator. So my standard deviation should be 3.02 rounded on my calculator. Then, if I want to quickly find my variance, variance is O squared. So I'm just going to square the 3.02. And my variance should be 9.12. We will double check that in our chart right now. But that's how I can quickly find that on my calculator. Because you're going to need standard deviation quickly for when you do the z-score. So let's check if we're right. On the chart, let's extend our column. I'm going to find variance. Which means now I'm going to have the x minus the m, and I'm squaring it. So now 1.8 squared, 3.24. 4.2 squared, 3.2 squared. 1.2 squared, 2.8, 3.8 squared, sorry, forgot to square it, 14.44. So now again, I add up that whole column and then divide by 6. So the reason we are a 10th off is because of the fact that this didn't have as much rounding in it, but it's very, very close, so that's okay. Either answer would be accepted. So now the square root, and it's 3.02. trying to get it so you can see it more. I can get it to show both on the thing. There we go. It's very close on the thing, but you can see how we got the same answer. So you can zoom in and out. There you go. Hopefully that you can see it okay. Because that's what we got longhand. That's what we got using the calculator. So this is all calculator. It's okay to use the calculator to do this. It's okay. The only one you can't is MAD. MAD, you got to work out longhand. But I've shown you, you get the same answer working it out longhand. Using our same data, same 5 values, now I want to do a box and whisker plot. What's nice about the box and whisker plot is all your 5 sets of values. Someone asked me, what are the 5 values? The 5 values are the low extreme, which on the calculator says minimum, quarter 1, which is the lower quartile, if you remember from FOA or FOA 2. Quarter 2 is my median. Quarter 3 is my upper quartile. And then I have my high extreme, which we know in the calculator says max. So now I already have this data in my calculator. So where again do I find the 5 data points for the box and whisker plot? Excellent. It's under 1 var stat again. So I come under stat, calc, because I already have my stuff in L1, because remember, I'm just going to go back to L1 really quick. Oops, sorry. I already had these saved in my thing. I didn't have to do anything else with them. I didn't delete them out. On your test, you're going to have several that use the same information. Use the same information. We're trying to make your life a little easier. So stat, calc, 1 var stat, enter twice. I have that end down arrow button, so I'm going to scroll down, and there, N tells me I have 6 data items, which I do. My minimum is a 66. My quarter 1 is a 67. This is 70.5 is my median, which is very close to my average, so that's good. 73 is my quarter 3, and my max is 74. Those are my 5 data items. Again, that's under 1 var stat. Scroll down. Now, on your test, if it asks you to go ahead and graph it, it is on a number line. But remember, on a number line, you don't have to start with 0. My lowest point, I can count by 5s, is 66. I go 65, 70, 75, sorry, 80, and I don't even have to go any further. Just like we told you, you shouldn't leave an empty graph. So now, I want to go ahead and graph these 5 points. So this makes my box, and this are my whiskers. So my low extreme is 60, that's my whisker. Let me do my box first. 67, 70.5, and 73. This makes my box. And then my whisker goes a tiny bit, and my whisker goes a very tiny bit. Because my box is so squishy, with my whiskers being so squishy, it means all my data is so close together. All my data is not spread out very well. It's all close numbers. All right, number 8. We're almost done. Number 8. We only have, 9. Okay, 9. So on number 8, we're again now going to do the z-score. We've already found the mean of this set of data quite a few times, but now we're going to find the mean score, the z-score. Remember the difference of what we did. As I kept saying in class, MAD, variance, and standard deviation talk about everybody. The z-score talks about how you individually go against everybody. That's kind of how the difference is. Z-score is personal, where Everything else is the whole group. So here, we already know from our previous stuff, I still have it on my calculator, that my median is 70.2. Same data I've used for every problem. We know that my standard deviation we found was 3.02. Okay, so now, if I want to find a z-score, it's individual, so I've got to do it 6 times. Again, I'm going to make a chart because I like the way it organizes my information. I'm all about easy to read, easy to follow. So we know that the formula for the z-score says the data point minus the mean divided by the standard deviation. All right, the hardest part about what you're doing is the calculator. Be careful. Right here, you need to know that when I'm doing this on the calculator, either A, put this in a parenthesis and then divide it, or B, hit enter and then divide it. Either way, you've got to lock that numerator. If you don't, your answers will be completely wrong. So I'm going to write out the first one. The next one I'm just going to kind of tell you and do it. So 70 minus 70.2 divided by 3.02. Then I'm going to do it again. 66 minus 70.2 divided by 3.02. Again. It says we're going to round to the nearest hundredth, so what does all this mean? What you have to understand about a z-score is it talks about this right here, the number of standard deviations it is from a mean. Because you know that a z-score of 0 equals my average number. So if I had the number 70.2, my z-score would be 0. Because that's going to be a question somewhere. I don't remember if it's here or if it's in a recital packet, but it's going to say so-and-so got a z-score of a 0. What does that mean? It means he scored the average on the test. So what this means is he's 0.6 standard deviations from the mean. So from the average, he's above it. He's negative 1.39, so he's 1.39 standard deviations below, sorry, this was above. It was above. Below the mean. So he's right now below average on my test. He's below average on my test. He's below average on my test. Above average, way above average. That's what it means. It's standard deviations from the mean. They are tiny numbers, but that's what they mean. How many standard deviations? Which means that the standard deviation is 3.02. He's whatever the mean is minus 3.02 something. That's what it means. You're subtracting that standard deviation without even having it. They're all individual scores. You have 6 individual answers. So what do we do to apply standard deviation? z-scores. That's an excellent question. Here is a question about how we're going to apply a z-score, or why we'd even want to apply a z-score. It says here that here's our test 1 and here's our test 2. The average on test 1 was a 75, the standard deviation was a 5, and you had an 80. On test 2, you had an 88, the mean was an 88, standard deviation was 15, but your score was a 75. So I told you I would drop the lowest test based on the z-score, but you're going to have to tell me which test I'm dropping. So, which one? Well, let's see. Test 1, I'm going to have to find the z-score. test 2, I need to find the z-score. Why? Because I need to find out how I relate to the average of the class, because that's going to determine whether or not I want to drop it or not drop it. That's what I want to know. Do I want to drop it? How do I relate to the class? How's my grade going to make it happen? So I'm going to want the one that gives me the better answer. So for test number 1, we know that z-score is my data minus the average divided by the standard deviation. So 80 minus 75 is 5. 5 divided by 5 equals 1. So here I scored above the average. Well, both of them I scored. Well, I don't want to score below. Here, my z-score, I'm going to take my number, 75, minus my score minus the average, divided by my standard deviation. So here, my z-score ends up being so based on these two z-scores, which one do you want to drop and why? Well, if I'm basing it upon the z-score, this test I'm below average. This test I'm above average. But I'm above average way more than I'm below it. This is a higher score. Why? Because he's furthest from the mean. I want this one because here I'm above average. I'm above the class. Not much above them, but I'm above them. Here I'm below average, which means on my z-score, my test is not so hot. I could be looking into a D range if she does it based on z-scores. Here I could be looking into a B range. So therefore, I want to go ahead and I want to drop. So this is a better score. So this test is the one that I'm going to drop, because it's the test that is below average. It's below the average. It's below the average. You need to think about what kind of grades you want and what you want to do, okay? So you have to put it into scenarios. Because remember, we talked about some scenarios you want to be below average. Some scenarios you want to be average. Some scenarios you want to be above average. If you're talking about a bell curve in grades, I always want to be above average. Why? Because it's going to get me the B or the A. The C is average. Remember, it's a little different than how you think about grades. Here, I'm below my average. I'm probably in my D range. I don't want a D. So anyway. But there's going to be some questions where you're going to have to think about, one, it's grades. You want to be above average. But you might be swimming. With swimming, I want the fastest time. I wanted to be below average to be swimming. To be average, if I'm talking about my blood pressure, I want to be right as close to average as I can be. I don't want to be, this would be a better score because, I want to be as close to the average. I don't want to be below. I don't want to be above. So based on the scenario, think of where you need to be. Have a great day, and if you have any questions, please bring them back to your homeroom teacher. Thanks.